Okay, welcome everybody. We have an interesting question. Foremost, I will have to draw the circle. So this is the all important circle. Fair enough. Now I have to draw another circle. So let's do that. Okay, so we have another quarter circle or a part of a circle being present inside the parent circle. Now we have a hit on the circumference. And this has been created by this chord, and we also have another hit. This is being created by another chord. This point is P, and the angle created here are of the same dimension. That is to state that the angle in this wedge is same as this wedge. Okay, I hope you are able to catch that. Now this entire angle, this is given as 90. Okay, this is the figure we will be using, and this is alpha, this is also alpha. I already mentioned to you this entire angle is equally split. Now alpha is the inscribed angle here, so that means the arc which is responsible in subtending the angle alpha, I'm going to write the statement here. QR is the arc that subtends the angle alpha, which is an inscribed angle. Okay, so that means if alpha is the inscribed angle, then the arc QR would be equal to 2 times alpha. Also, if you observe here, RS is subtending the angle alpha, which is also an inscribed angle. So subsequently the arc RS would also be equal to 2 times alpha. Okay, fair enough. Now what I wish to do is I would like to connect the point O, which is over here, to Q, and also O with R and O with S. So if we were to do that, then clearly we would have a triangle like this with O, Q, R. Now this is actually the distance between the center and the point on the circumference. So this is going to be our R, and this is also going to be our R. Now this arc QR will subtend an angle at O. QR will subtend an angle at O. Okay, now since QR is equal to 2 times alpha, this means angle at O will also be equal to 2 times alpha. So this angle will also be equal to 2 times alpha because QR is 2 times alpha. Also, if we consider the triangle ORS, I am considering ORS, then arc RS will subtend, because RS is 2 times alpha, so therefore arc RS will subtend an angle at O, with angle at O being equal to 2 times alpha. Okay, so this is also going to be R, this is also going to be R, this is going to be 2 times alpha. So comparing triangle QOR and triangle ROS, we find that triangle QOR is congruent to triangle ROS. Okay, side angle side. So this would mean QR, the distance QR, will be equal to RS. So let me take that to be equal to X. So that's exactly what I am doing here. So I'm taking this distance as X and this distance as X. So now what we are going to do is we will be applying the cosine rule for Q, P and R. So consider triangle. I'm just going to consider triangle Q, P and R. Okay, this distance is X. Now this distance is 7 units and the other distance is 3 root 5. So 3 times root 5, and we are taking this angle as alpha. Okay, so we want to create a system for x squared. So x squared is equal to 7 squared positive 3 times the root of 5 squared negative 2 times 7 times 3 times the root of 5 multiplied with cos of alpha. Okay, so now we will be considering the other triangle, which is going to be our RPS. Okay, RPS, and this is 3 times the root of 5, and this distance is 5 units. Okay, so this is X, as I mentioned to you, and we will apply cosine rule. Okay, so by cosine rule, so this is x squared is equal to 3 times the root of 5 squared positive 5 squared negative 2 times 3 times the root of 5 times 5 times cos alpha. So I take this as 1, I take this as 2. We can equate 1 with 2. Equating 1 and 2, because x squared is there, right? So we would have 3 times the root of 5 squared positive 5 squared negative 2 times 3 times the root of 5 times 5 times cos of alpha is equal to 7 squared positive 3 times the root of 5 squared negative 2 times 7 times 3 times the root of 5 times cos alpha. So you bring these two to the other end, right? So in fact these two gets cancelled, right? So you will have 5 squared negative 7 squared. You move this to the other end, so you have 2 times 3 times the root of 5 times 5 times cos alpha negative 2 times 7 times 3 times root of 5 times cos alpha. Now this is 49, so 25 and 49, you have 24, right? So this is negative 24. I'm going to take 2 out because 2 is present. I'll take root of 3 times the root of 5 out. So these two are taken out, and that would mean I will have 5 negative 7 multiplied with cos alpha, right? So this is going to be 2 times, you have a negative 2 there, and 3 times and a root of 5 times cos alpha is negative 4, negative 24. So negative positive, right? So 2 divides here 12 times, this 2 divides here 6 times, 3 divides here 2 times. So you have 2 is equal to root of 5 times cos alpha. So cos alpha is equal to 2 over root 5. This is what you are getting. So if I were to go and represent this, so cos alpha is 2 over root of 5. That's exactly what we have got. And if I'm were to take this point as alpha, this is opposite side and this is adjacent side, this is hypotenuse. So hypotenuse is root of 5, adjacent is 2 units. So if I were to take this as some TSP by Pythagoras, what do we have? By Pythagoras rule, TS squared plus PS squared is equal to TP squared. TP squared is root of 5 squared. TS squared is 2 squared, and PS squared we need to know that. So PS squared is equal to root of 5 squared is 5, negative 4, which is 1. So PS squared is 1. Therefore PS is equal to 1. So sine of alpha is opposite side divided by hypotenuse, which is nothing but 1 over root of 5. So sine alpha is equal to 1 over root of 5. That's a very important data that we have got there. Okay, so having got this sine alpha, now it's time for us to go and get the radius. Now you see here, this is the figure that we have got. Now what I'm going to do is I would like to, x is already got, right? The value of x, in fact we have to get x now because we have just got cos alpha. So let's just get x. So we know that x squared is equal to 7 squared positive 3 into root of 5 squared negative 2 times 7 times 3 times the root of 5 times cos of alpha, right? So this is 7 squared is 49, 3 squared is 9, 9 into 5 is 45, negative, you have 7 twos are 14, 14 multiplied with 3, what do you get? 3 fours are 12, 1 3 ones are 3, 42. So you have 42 there, and you have root of 5, and cos alpha is 2 over root 5. We already got that, so these two gets cancelled. Now if I were to add the 49 with 45, this is 4 and 94, minus 2 twos are 4, 8. So 94 minus 84, this is going to give me 10. So x squared is equal to 10, therefore x is equal to root of 10. Okay, fair enough. So we have got that value for x. So now what I wish to do is the side. What is the side? The side is root of 10. Okay, root of 10 divided by sine alpha is equal to 2 times r. So this is a very important property for a triangle present inside a circle. This is sine rule. Okay, I'm just using sine rule, so let me use it. So by sine rule we have, what do we have? We have root of 10 divided by sine alpha is equal to 2 times r. R is the radius of the circle. So sine alpha is 1 over root 5. So this is 1 over root 5 is equal to 2 times r. So 2 times r is equal to root of 10 times the root of 5. Now root of 10, I'm going to write it as 5 multiplied with 2. You have a root of 5 there. This can be rewritten as root of 5 times root of 2 times root of 5. Root of 5 into root of 5 is 5 times root of 2 divided by 2 times r. So therefore r is equal to 5 times root of 2 divided by 2. So this is what we have for the radius. But I'm going to take root of 2 as 1.414, right? So if I were to multiply by 5, what do I get? 5 fours are 22, 5 ones are 5, 6, 7. 5 fours are 22, 5 ones are 5, 6, 7. Divided by 2, 2 2 times 3 is 6, you carry 1, you have a 5 there, 10, and 3, 2 times 3 is 6, you have again a 1, you have a 5 there. So this is the radius, 3.535. Okay, now we have got the radius. Now the understanding is that we will have to get the area of the shaded region, right? So this is a very important step. Okay, now we go to the quarter circle. So 3.53, what is that, what value we got? 3.535. 535 is the radius of the parent circle. This entire circle is 3.535. Now this is the triangle, right? I would say this is 90 degrees, not a triangle. This is a 90 degree, right? Okay, so the triangle part is already finished. Now what I wish to do is I would like to draw a line connecting the point D with this point. Okay, so of course figure is not to scale, okay, because of the issues. Okay, so you have to connect this. There is a heat there. Okay, it's passing through the circle. I mean passing through the center of the circle. Okay, this is the heat. Now the important point is, will this pass through the center of the circle? You might be asking me, will the line pass through the center O? That's an all important question, right? That's a valid question. Now I am claiming it will pass through. Why? Because we see that there is an angle. We see that angle Q is equal to 90 degree, right? And this is actually part of a triangle, right? And this Q is a vertex of the triangle. Okay, so if we were to take it as well, we have taken this as what point is that? So P, Q, R, S, T, okay, U. We have taken this as U, right? The point is U. Okay, Q is the vertex of the triangle. What triangle it is? UQT. Okay, and clearly this triangle is, and the triangle created inside a semicircle. That's inside the semicircle, right? Is it not? This is one part of the circle, this is another part of the circle, this is inside the semicircle, and triangle created inside a semicircle will always have one of its angles equal to 90 degree, and by Thales theorem one of its side of the triangle will be the diameter. Okay, that is why I am saying that the line will pass through the center. Okay, so now what I wish to do is I will be applying what? Pythagoras theorem. So we will apply the Pythagoras theorem to the triangle UQT. So if we were to apply the Pythagoras theorem, what is this? This UQ squared plus QT squared is equal to UT squared, isn't it? Right? Yes or no? Fair enough, right? Now watch here, what is QT? QT is the radius of the quarter circle. And what is UQ? UQ is the radius of another, the same quarter circle. Alright, so this is R and this is R, right? So I'm going to state here, since UQ is equal to QT is equal to R, radius of the quarter circle. If I were to take this as say sum 3, therefore 3 is going to be R squared plus R squared is equal to UT squared. But what is UT? UT is the radius of the, or I would say the diameter of the parent circle, right? So UT, right? UT is supposed to be the entire diameter. Right. So this is the entire diameter, but R is 3.535. So UT is going to be 2 times of 3.535, and we will have to square that. So 2 times R squared is equal to, if I were to multiply this by 2 and 7, right? So this is going to be 7.070, and you will have to square this. So R squared is going to be equal to 7.070 squared divided by 2. I am going to write this 2 as root of 2 squared. So R is going to be 7.070 if I were to take the square root and divided by root of 2. So this is going to be my R. Okay, so this is the radius of the quarter circle. Radius of the quarter circle. Now we are interested in getting the area of the shaded region. Right, so if you were to go back to the figure, we need this, we need all this shaded region. So from the area of the circle, area of the big circle, we take away the area of the quarter circle, right? So area of the huge circle is pi r squared. R squared is 3.535 squared negative. Area of the quarter circle is going to be pi r squared. So it's going to be pi, and the radius, this is going to be the radius. So I will have to write this as 7.070. It's a square, right? So divided by, we have to square this root of 2 also, so that will become 2 there. But since it's quarter circle, we have to divide the entire component by 4, right? So 4 is present there. So this is going to be equal to pi times. Now what we can do is we can actually perform some simplification here. So let this be as 3.535 squared negative pi times. Now 7.070, so that is actually 2 multiplied with 3.535, isn't it? So that is raised to the power of 2 divided by 2 times of 4. Okay, so this can be rewritten as pi times 2 times 3.535 squared. You have a square there, and you have a 2 times 4 there. So of course this is going to be pi times of 3.535 squared. So a square and a 2 gets cancelled, and another 2 can also be used to reduce. So you have pi times of 3.535 squared negative pi times of 3.535 square divided by 2. So I take pi out, I take 3.535 square out, I will get a 1 negative, this is going to be 1 over 2. So 2 negative 1 divided by 2 times pi times 3.535 square. So this is going to be pi times 3.535 square. 2 negative 1 is going to be 1, and that's going to be divided by 2, right? So this is the area, required area. Let me write this down here. Required area of the shaded region is going to be pi times 3.535 square divided by 2 square units. Okay, so this is the solution for this question. Please like, share and subscribe. Thank you.